speaker, who is her boss, Paul Rush. He is the Deputy Commissioner of New York City Bureau of Water Supply for the New York City Department of Environmental Protection. Paul's a veteran of WWE, been here many times, and has been around a long time. And I think, if you polled many upper Delaware River watershed leaders, you would get a unanimous response that Paul has been outstanding in his ability to both do his job with the New York City water supply, but also be attendant to many of our issues that are most relevant and important to us below the New York City dams. And that's a testament to Paul's experience and perspective beyond just the New York City watershed, which we greatly appreciate. So Paul, thanks for coming today. We got a thing coming up next year. We've already had some preliminary conversations with you and your staff about it, but it could potentially have some big implications for the tailwaters and for you, of course, and that's the Delaware Aqueduct work that's going to start next year. So with that, Paul, if you have a PowerPoint, can take it over from here. Welcome. Thank you.
I'll attempt to do that, Jeff.
Okay.
Doesn't look right. This looks better. So Jeff, thanks for that kind introduction. The big event coming up next year is going to be a shutdown of the Delaware Aqueduct for 6 to 8 months in order for us to repair the aqueduct. And when I started with DEP in 1992, the thing I did on, I guess, the second day at work, I went over to New Paltz for a meeting about releases with DEC, DEP, a bunch of old timers that had just wrapped up discussions about a new releases plan. This was what, 92. And then a couple of weeks after that, I went down to see a potential leak on the Delaware Aqueduct in the town of Warsing that was a real leak. So this kind of ties both of those things together. So here we go. So this is what I'm going to cover. I'll try to move through the slide deck pretty quickly. Just kind of move these faces out of the way so I can see this. Okay, that's better. Go over a little bit on the Delaware Aqueduct, history of the project to repair it, our operations during the shutdown, some of the concerns we heard, and give some time for questions. I'm going to move pretty quickly through the slide deck. There are 18 slides. System overview, New York City water supply system, 19 reservoirs, 3 lakes, 570 billion gallons of storage, serves 9.8 million people. This is updated on the most recent census data from New York City, which showed a population of 8.8 million. Deliver about 1.1 billion gallons a day. The Delaware Aqueduct. So the Delaware Aqueduct is still in the Guinness Book of World Records as the longest tunnel in the world, longest continuous tunnel at 85 miles long. Provides between 50 to 60% of the city's water supply. It was first put into service in 1944 on an emergency basis during World War II. In 1948, it was put into permanent service. The last time it was inspected was in 1957 to 1958, was drained, drove a Jeep through it, and we haven't been inside it since then. It obviously is a critical component to the water supply system. It consists of 3 segments, from Rondout Reservoir to West Branch Reservoir, then from West Branch to Kensico, and the final leg of it goes from Kensico down to Hillview. The section between Rondout and West Branch is the area where we have identified leakage. The other sections, there's no leakage to our knowledge. So that's where we'll focus on, the Rondout to West Branch section of the aqueduct. So when the aqueduct was built, it was built primarily through sedimentary rock, shale for the most part. But there were 2 spots where there were challenges of going through limestone formations. Those were in the Rondout Valley and then approaching the Hudson River. And in those sections, there was steel liners put in to help give the tunnel strength in those areas. And you can see from the pictures here from the archives, construction techniques then were different than they are now. It was drill and blast. They'd use that device on the right-hand side there called it's not a jumbo. It's a device where they were able to drill a bunch of holes into the face of the rock and then blast and then go back in and dig out the rock and remove it of a shaft site. Today, we use tunnel boring machines for the most part in our tunneling techniques. So the leaks on the Delaware Aqueduct were first identified adjacent to the Hudson River, where Central Hudson Gas and Electric Corporation operated the Roaston Generating Station. They notified DEP that they thought there was a leak. And subsequent to that leak, back then, we'd periodically treat water as it moved from one reservoir to the next with copper sulfate when we had very, very high phytoplankton counts. And we did some treatment at Rondout back in 1990. And we were able to identify that same copper was picked up at Roaston. So it was 100% confirmation that the water coming out adjacent to the Hudson River there in the town of Newburgh was Delaware Aqueduct water. A little bit later, we were contacted by a homeowner in the town of Wawarsing who had water on her property and noticed that the water had gone away and asked if we had been working on the tunnel. It turns out we had shut down the tunnel for a couple hours and the water went away. And that was what I was assigned to follow up on, was that leak and monitor it. And we did a lot of work to try to understand the leakage. And we calculated the leakage would vary from about 14 million gallons a day to as much as 36 million gallons a day, depending on what flow we were pushing through the tunnel. And it would only go over the 30 million gallon a day at our highest flow rates, which we typically don't operate the tunnel at anymore. So on a typical day, we're losing about 20 million gallons of water a day. So that's the amount of water that would be saved from the system when we fix the repair. About 95% of that leakage appears in Newburgh, and only about 5% is leaking out in Wawarsing. And we'd confirmed that. It took us a long time to actually document that, but we actually used an ROV several years ago in the Wawarsing section that really showed that the biggest place where we have leakage and our biggest problems adjacent to the Hudson River. So this limestone rock that we encountered in these two locations, it was faulted, it was tough to get through. There was a lot of in leakage coming into the tunnel during its construction at both spots. Steel lining was installed to provide support in those areas. And what we think the issue is the steel lining was not long enough. It's just outside the steel sections where we're getting these leakage. And it's really not a surprise that this is developed, that the water's reached the surface, because one of the selection criteria for the city in going to the Catskills after the Croton system was complete and there was still a need for water, was trying to find a place with soft water, low calcium concentrations. And the water that comes out of the Catskills is softer, much softer than we get out of our Croton system. And because it's so soft, it has the ability to dissolve limestone very readily. So water did leak through the limestone around the tunnels, and it created fissures that reached the surface. And this little video, I think it might play. Jen, you said it was going to play. Apparently it doesn't. Oh, well, that's just water bubbling up near the Hudson River in Roaston. So the areas where we have the leakage on the map, you can see Roaston and the town of Newburgh in Orange County, and the other area in Wawarsing in the town of Wawarsing in Ulster County. And when we do the repairs, which I'll get to a little bit. When we do the repairs, we'll be doing a bypass tunnel under in this section, and in the Wawarsing section, we're actually going to go in and grout the small area of leakage by going into the shaft 2A, which is in the Shawangunks at about 2,000 feet. So we had a leak. We knew about it in 1992, and we knew we had a problem, but fixing the problem was something that would require a lot of work and understanding to try to figure out what we were going to do about it. Because at that time, demand was much higher in the city, and the Delaware system, going without that for any extended period of time, was something the city would not be able to get through with at all. So one of the first things we did was to work to try to do a look through in the tunnel. And we contracted with Woods Hole Institute out on Cape Cod and a company out of Canada to develop an autonomous underwater vehicle to drive through the tunnel, fly through the tunnel. You can see a picture of that on the lower right. And that was used in 2004. And after the results of the inspection in 2004, one of the things that it did show us, there were no gaping holes in the tunnel, but there were small cracks in the section, particularly around Rosedon. So that told us at least we didn't have a gaping hole we were dealing with. It was small cracks. And then we flew the tunnel 2 more times just to check on and help aid in our design and our approach. We also used an ROV in Wawarsing. I had mentioned that's on the upper left-hand and upper right-hand sections. That was lowered in by that same company out of Canada that was used to identify and analyze the leak in the Wawarsing area. So 92, and this is a chart of the population of the city and demand. And this is just in-city demand. And as you can see, back in 1979, peak demand in New York City was about 1.5 billion gallons a day. You can see back in 1966 in the drought, how efforts were made to cut demand further during that time. We were down to as low as about 1 billion gallons a day. And when we had this problem present itself, 1990, right about there, you can see how high that demand was still at that time. But a lot of work was done in city to reduce demand, pushing out universal meter reading and eventually automatic meter reading that's really served to change behavior of customers to reduce use of water. We also had programs that replaced shower faucet heads, toilets over time, and then just the developments in the industry and EPA standards with smart technology that uses less water has resulted in a decrease, a tremendous drop in our demand, despite increasing population in the city. So when we first were faced with this, the idea of one of the biggest planning things was where we were going to get additional water to be able to shut down the Delaware Aqueduct. And the thought at that time was we'd have to build perhaps we'd have to build an entirely new aqueduct to take the Delaware system out of service. First, build a new aqueduct, and then take it out of service. But as demand decreased, that really set up the stage that we were able to develop a plan to fix the tunnel. And the plan that we came up with was build a bypass tunnel around that leaky section. This is starting in Newburgh, going underneath the Hudson River, and then connecting it on the other side of the Hudson River around that leaky section. And this tunnel itself, this 2.5 mile section, is complete and is, this final lining stage is what's going on right now. The last part of the work will be to build the connections into the Delaware Aqueduct. And when we build those connections, we can't have any water flowing through the aqueduct, so it will be unwatered. And for the time it's going to take us to make this connection and put the tunnel back in service, we're looking at 6 to 8 months. And while we do that work to connect the bypass tunnel to the existing tunnel, we'll also be working up in Wawarsing to do the grout repairs in that section of the aqueduct. So the shafts were completed in 2017, the vertical sections down into the tunnel. We built out these bailout chambers that allow us to access equipment and work to get in and build the main tunnel at the same time. The tunnel boring machine got through the tunnel in 2019. The rock was brought up on the Newburgh side and was actually placed on a section of land that we had purchased adjacent to the site, which saved a lot of truck traffic from driving up and down Route 9W there. The steel liners were installed and the final concrete lining the bypass tunnel was finished in March of 2021. And there's still prep work that's going on right now to make that connection, which is planned to start in October of next year, so about a year from today. And we expect to have that work complete and the Delaware Aqueduct restarted by April. The plan is to do it in one season. We have contingencies. If there's a problem, we need to bail out and put the tunnel back in service, the old tunnel, or a partially completed new tunnel, where we have contingencies where it could take up to 3 seasons to do, but we expect to do this in one season. So Bureau of Water Supply, our mission is pretty simple. We reliably deliver high quality drinking water to protect public health and the quality of life of the city of New York. And this is just an area on the left-hand side of a Shokan reservoir and the Catskill, Delaware UV plant down in Westchester County, where all of our unfiltered water that comes out of the Catskills is treated. And to do that, I mean, getting water to the city is number one, and the essential task is to make sure the city has enough water. We also have the essential task of meeting all of our commitments regarding reservoir releases and limits on our diversion. And we do this to make sure we have a dependable supply. We try to divert the best quality water available while maintaining a balanced system. And at the same time, and what we change over time is we also look for water that's not going to be released, which is not going to be diverted for consumption, that it provides the best use downstream. So we've worked to provide, habitat benefits and also providing these voids to increase the flood attenuation the reservoirs provide. And this is Cannonsville Reservoir from back in 2001, when it was about 3% capacity. And this is record elevation at Cannonsville Reservoir from back in the floods of June 2006 on the bottom. So when the Delaware Aqueduct shut down, we're going to need to make up additional water from other parts of our system to get through. And right now, the Catskill Aqueduct is shut down to do the final stage of work to increase the capacity and reliability of that aqueduct for the Delaware Aqueduct shutdown next year. The Catskill Aqueduct had a capacity of about 590 million gallons a day most recently. There's some documentation that shows when it was first placed in service, it could deliver up to 640 million gallons a day. The work we are doing right now and have done over the past 3 years has been to remove biofilm that's built up inside the aqueduct, and also to repair leakage that we've had in certain spots on the Catskill Aqueduct. And the Catskill Aqueduct essentially is a cut and cover aqueduct close to the surface. It's easier to access than the Delaware Aqueduct. We've scraped off this biofilm, and by scraping off the biofilm, it reduces the roughness of the aqueduct, and that should allow more water to push through the aqueduct. But the Catskill Aqueduct is an open channel flow aqueduct, so it flows more like a river than a pipe. And unless we are successful in removing biofilm and dealing with friction issues along its entire length, I mean, we could do 90% of it, but if there's a bottleneck, you're not going to get the increases in capacity. Some of the preliminary work we've done has shown that for the same amount of water, we can move at a lower depth than we did previously, so it's moving along with more energy. We hope to get greater than 600 MGD out of the Catskill system for the shutdown next year. The other thing we've done is at Cross River Reservoir and at Croton Falls Reservoir on the Croton system in Westchester and Putnam counties, there used to be hydraulic pumping stations at those locations that would pump water into the Delaware Aqueduct during droughts. The hydraulic pumping stations ran on water power. I meant water that was released from the reservoir, spun a turbine, and then water was also pumped into the aqueduct using that hydraulic turbine. But there was a lot of water that ended up going downstream into the Croton Aqueduct and then could potentially be lost out of the system through those types of operation. So we invested money to put electric pumping in at Cross River and Croton Falls. And between those two pumping stations, we expect to be able to get 240 MGD into the Delaware Aqueduct during the shutdown. And this doesn't create additional storage. It just allows us to take more of that Croton water into the distribution system than we could otherwise during this short period of time when the Delaware Aqueduct is going to be out of service. The Croton system itself, out of Croton Reservoir, we now have a filtration plant put into service with a capacity of 290 MGD. We plan on running that at close to full capacity during that period, that 6 to 8 month period starting next year, to allow the city to be able to get through the shutdown without coming up short with water. So for the Delaware Reservoir operations during this time, we've done a lot of modeling, did a lot of modeling to support our operation plan that appeared in our EIS. And, we did model to make sure that after we do the shutdown, we're able to refill the system by the spring of 2022. So ahead of the shutdown, that means starting this year, coming up into 2022, we're going to favor the Delaware system and take more water out of the Delaware system to bring down storages in Papacton, Cannonsville, Neversink reservoirs, in addition to Rondout Reservoir ahead of the shutdown. So we'll take more water out and lower them. And then during the shutdown, we're just relying on the Catskill and Croton systems. Releases will be made throughout the shutdown with the goal of keeping storages below the CSSO. So we'll be very proactive in lowering the storages ahead and making releases to keep those storages down below the CSSO during the shutdown. Concerns we've heard, reservoirs being too full during the shutdown, installing siphons at Papacton, Cannonsville, and Neversink reservoirs. We're going to be operating to keep the storages low during that time through releases. We have that flexibility under FFMP to look ahead in terms of understanding releases. Like, we've had these very large releases that have been going on for some time out of Papacton, Neversink, and Cannonsville releases as a result of the tropical storms that we had recently. There have been questions about why we've been keeping them up so high. We've been trying to get the system under the CSSO and keep it there. And we've been taking quite a bit of water out of Cannonsville as well into Rondout. We've begun to decrease the releases a bit out of Cannonsville. There will be siphons installed at Rondout Reservoir. The reason they're there at Rondout Reservoir and not at the Delaware reservoirs, at Rondout, normally most of the water leaves out of the Delaware Aqueduct, and we have a very, very small release mechanism at Rondout that only provides a max release of 15 million gallons a day. So that's why they're installed there. We spent a lot of work planning, a lot of time planning this work. It was a public process, more than 20 years in the making. We're using the best models we have, the best forecast information we could get. And although we don't have a crystal ball to predict the weather, we'll be watching elevations and making proactive actions to make sure we meet our commitments during the shutdown. So the system itself has benefited from wise investments in infrastructure over time. Fixing the Delaware Aqueduct makes for a much more reliable system. It's definitely 20 MGD less water that will be lost from the system. That means more water is available for other uses. We have to maintain a state of good repair, stay on top of the research, regulatory trends, climate change, and others, adjust our operations as necessary. And it's important for us to also maintain dialogue and listen to concerns and ask questions and have, be completely transparent and open as we possibly can be. What you see on the top is a picture of the tunnel boring machine that was used to bore the tunnel under the Hudson, and that steel lining that was coming up on a barge from Louisiana to be delivered in Newburgh and was put into the tunnel. So that concludes my presentation, subject to your questions. Thank you.
Thank you so much, Paul. That was great. We do have a bunch of questions and a couple comments. Maybe most importantly, Dan Plummer wants to make sure you know that you have excellent lighting over there. Didn't want to forget that.
Thank you, Dan.
And then Nathaniel Gillespie just put a compliment in here, noting that your water conservation work to decrease the water demand is excellent. And then we have a couple of questions about what's happening with that 20 million gallons per day of water that, will be safe and sound now, or, once the work is complete, and can it be used for conservation, recreation purposes?
So once that water, once we fix the leak, that's less water that's leaving the system. And this is water that was coming out of the Delaware system. It makes more water available for other uses. So when there's the calculation that's done on the FFFP determining what table we're in, that's 20 MGD more water that's available in the system that's not being wasted, effectively reduce our demand by that much. During the shutdown of the Delaware Act, we're going to be relying a lot on the Croton system, and operating a filtration plant, the one at Croton, that's been something we had never done before until 2014, 2015. And filtration plants, what we have found is when you shut them down, restart them, that's a very difficult process. It makes sense for us to, even beyond the shutdown, to keep the Croton filtration up and running, delivering water at least to the low service section where it doesn't have to be pumped in the city. Our plan long-term is to keep the Croton filtration plant and Croton system up and running, at least meeting probably 90 MGD a day. And if we're facing dry conditions, we'd increase that as a way to just ensure system reliability. So that's something that we had not done prior to 2014, all the way back into the early 2000s. So that means that's less water we have to get from Delaware or from the Catskill system. And with the work we have done on the Catskill system, we should have more flexibility to take more water out of that in the future. So I think there's a benefit overall in having more water available to release as a result of this work we're doing.
Okay, thank you. And then the last question is, considering you haven't been in the aqueduct for any meaningful repairs in over 60 years, what, if any, are DEP's concerns during the shutdown?
Yeah, this is the first time we're going to dewater the tunnel. Number one, when we shut flow off right now at Rondout, the tunnel itself stays filled with water. It's deep underground. It runs at about 600 feet below sea level in spots. So as we pump out the water out of the tunnel, we're concerned, there could be sections of the tunnel where there could be concrete that comes loose when we dewater. Just pumping that out, how much debris we may have to remove out of the bottom. And then, being able to get the tunnel restarted, making sure that the new tunnel is solid, the connection is good when be able to restart it. That's a concern. My number one concern is just making sure that all our other systems operate well. We're going to be relying on the Catskill Aqueduct. We're going to be relying on these pump stations, and the Croton plant is really, those are concerns that I have overall for supplies, for making sure that we have enough water to meet New York City needs and comply with all the regulations we have. One of the things that we will do is, our Delaware water tends to have very, very low turbidity. At a Rondout, we typically have less than 1 NTU. And that's a result of the characteristics of the water from Pepacton, Canonsville, Neversink, and the Rondout Basin. Over in the Catskill system, and those who have fished over there know that the Schoharie and Esopus tend to produce more turbidity, especially in big storm events. So having turbidity increase in Catskill Reservoir is a concern, and we're going to be proactively, we'll be treating with alum at Catskill Reservoir to keep that turbidity down. So that means that treatment system has to operate reliably, and we have to have reliable delivery of all the chemicals we need. And given all these supply chain concerns we hear about, I mean, that's, right now it looks all good, but who knows what could be coming in the future. So those are just a few of my concerns. I could keep going on about this. This is going to be.
Well, we did have another question come in. So is there any consideration for permanent siphons in Canonsville for future repairs?
So we have so one of the things we have still on board as a possibility is a design of a hydroelectric plant at Canonsville Reservoir. It's going to require a shutdown. We're going to be needing to make releases during that shutdown. During that period, we may be, the plan is to put siphons in, but at Canonsville Reservoir, we have a huge capacity to release, especially compared to the others. And similar work was planned up at Pepacton Reservoir, replace valves there, which need repair, where we're looking at a pumping system to get water out of Pepacton. But those projects are out beyond the time frame of the Delaware Aqueduct shutdown, but we do not have plans for permanent installations of additional capacity at either one of those plants. If the hydroelectric plant is installed, that would also slightly increase the capacity and our ability to release water out of Canonsville.
Okay, well, I think that's it for questions. Dan has an interesting fundraiser idea he put in the comments if you'd care to check it out, but otherwise, thank you again.
Thank you, Molly. Thank you, Jeff. Thanks for listening to me today.
Thanks, Paul. Much appreciated. And we're